you're in the military, okay? Got all these new rules you got to follow and so on and so on. All right, and one of your rules are you are walking with someone who's a higher rank than you. Okay, well, first of all, when you engage with that individual and you first meet up, you salute him. Okay? Now, when you two are about to walk through a door, all right, you are the one to open that door and let him in. Okay? What these are called are protocols. These are rules that you're supposed to follow as you're in the military. Okay? Now, I wouldn't know. I've never been in the military. But at the same time, if you don't follow these rules, what you have done was you broke protocol. Going up the chain of command, meaning that you want to complain about something, you don't tell your commanding officer. All right, you go directly to your commanding officer, and he'll take it up to his commanding officer, and so on and so on and so on, and it goes as high as it goes. Okay, over not taking that route and skipping your commanding officer and going 2 or 3 people up to get to the general, you are breaking protocol. Okay, you're not following the rules. All right, now. Every company has protocols that they need to follow. Okay, it's called the company handbook, right? Now, what about protocols as far as technology is concerned? Okay, and I want you to understand something. Don't overthink this. Okay, it's very easy to do. These protocols, guys, are already created for you. That's it. Okay? All you have to do is use those protocols the way they should be used. Okay? So, how do I utilize Ethernet as a protocol? Well, check this out. No. Yeah, that's it. Okay. Now, my Ethernet, that's wireless. Where's my wiring connection? No, it's not. No. This is it right here. Okay. All right. Now, how I use Ethernet is I go underneath that adapter in my control panel under networking, and I double click on TCP/IP version 4, IP version 4. Okay. And I actually go in here and I'll type in an IP address, 192.168.1.1. Okay? Give it a subnet mask, and trust me, you're going to learn this stuff. All right? And give it a default gateway, 192.168.1.10. Okay? And we'll give it some DNS. Hit OK. And guess what? We never hit OK again. Let's try doing that. Oops. I'm fat fingering the hell of these things. Ba, 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 ba. Where the hell is my adapter? Ethernet 2. Where's Ethernet 2? Ethernet 2 is right here. Where did you get this IP address? It took the default gateway, 1.10. Why didn't it take the IP address? Everything's in there correctly. Let's disable this bad boy. That's weird. I wasn't expecting that. IP config. And I do not see Ethernet 2. Did I uncheck IP version 4? No. IP version 6. Get rid of that. I swear, guys, it really is just as simple as this. What the hell? Okay. I don't know why it's doing this, but nonetheless, it is as simple as that. Okay. Let me try this. Unplugging the USB, plugging it back in. Okay. Let's unplug the adapter. The Ethernet cable. Guys, I've never seen this. This must be a Windows 10 thing. I've never seen this before. All right, so now the adapter doesn't come up, which makes sense. Okay, you know what? Let's go a different step here. Okay, I don't know why the interface is a 169 address. That makes no sense whatsoever because I'm not using DHCP. That is so odd. You have no idea. Okay, it should have the IP address in there because we manually put it in there. Nonetheless, let's go ahead and obtain an IP address by going back to do it automatically, which is DHCP. Okay, and as you can see, we picked up an address. All right. That failed. I don't know why it failed. That's weird behavior. It's not supposed to act that way, especially when I statically put an IP address on an interface. It should come up under Ethernet 2 as an IP address. Don't get me lying. It must be a Windows 10 thing. Who the hell knows? And you know what, guys? I'm over it. To be honest with you, I'm not even trying to figure that out. And you know what? I bet you I know what it is. I bet you I know. I bet you this is the reason right here. Windows 10 Home. That's something I have to research later on. I guarantee if I had Pro on here, Windows 10 Pro, I bet you it would actually do that. I think that's really one of the biggest difference is the network features. So, so sorry about that delay, but you know, oh well, won't be the last. Okay, so now, what is Ethernet? It refers to a LAN of products. Okay? All right? It's under the IEEE 802.3. Now, what is IEEE? All right? Institute of Electrical and Electronic Engineers. Let's go in there. Okay. IEEE.org. Okay. You can go as far as you want with this information. Okay. What I'm trying to tell you is this is a documented protocol that has rules and regulations that you must follow if you want to create a network card so it can communicate with other network cards. They're standards. You can create your own version of Ethernet. Okay? But that's only going to work if both the computers are using your particular network card that you have encoded that protocol onto that network adapter. Does that make sense? Okay? Or maybe you have, and let me rephrase that. Okay? The drivers that you're going to be using for your network card, they're going to use that hardware in a different fashion because it's proprietary. It's your way. You want your network cards to work a certain way. All right. The only way, okay, that's going to work is that means I have to download your particular software, all right, to get your hardware to work, to follow your rules, okay, and it can't work with any other network card. They must all have your network cards, okay, and that's fine and dandy, okay, until you go to another vendor, and the vendor's like, I'm sorry, we follow IEEE standards across the board. I'm sorry, but, our devices are not going to work with your network cards. All right? 802.3. Boop, 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 boop. 802 standards. Family and network standards and recommended practices for local, metropolitan, and other area networks. Okay? Here's 802.3. All right? And you can read. Look at all these 802s. And here it is. 802.3 is what? Ethernet. Okay? All right? 802.11 is wireless. Click on Ethernet, and guess what? Look at all this. We got reading for days, guys. Okay? What I'm trying to tell you is the work is already done for you. How deep did you need to know how the Ethernet protocol works? You don't. I mean, you really don't. You don't need to know exactly how the protocol works. You just need to know how to enable it and get it to work. Period. I don't need to know how, okay, putting a port in a VLAN, how that command is coded line by line. I don't have to do that. I just need to know the command, switch port, access, VLAN, whatever. Okay, I know that particular command does enough coding to move that port into an actual VLAN, and I'm done. Okay, from my perspective, I'm over it. Okay, what I'm trying to tell you guys is you can go as deep as you want. If you think you're going to learn everything about everything, you're crazy. It's never going to happen. But you can try, and I'll see you in about, I don't know, after death. Because that's exactly what's going to happen. And you're still not going to be anywhere close all that time you put in. Okay? So, it is a protocol. Now, Ethernet was designed from the concept of allowing multiple devices to be on the actual network, but something sitting in the background monitoring that wire. Now, take a look at this. Remember when we talked about the walkie-talkie example? Push the button. Nobody else can talk. Okay? Nobody else can talk. But on a telephone, you can. I could be talking to you while you're talking to me, and I can hear you while I'm talking. Okay? All right? when I push a walkie-talkie and only I'm talking and everybody else is listening, and if anybody else pushes that talk button, they can't hear me anymore. You're transmitting to transmit. Okay? Not going to work. All right? Now, with a telephone, though, you can communicate. You can transmit and receive at the same time. Transmitting and receiving at the same time is called full duplex. Right? The other one's called half duplex, meaning that I'm going to have one communicator at a time. Now, check this out. Ethernet works in a way where I'm monitoring the wire at all times. The network card is doing this. Okay? And if two people communicate at the same time, guess what happens? Transmit. They collide. The voltage changes on the wire. So now what happens is everybody on the network gets a stop message. Everybody stop transmitting right now. Stop. And then randomly everybody gets a half second, quarter of a second, 1/3 of a second. Okay? Gets a time interval before they can start transmitting again. Okay? That transmit collision is called a collision. Okay? So as we are putting stuff on the data, all right, this carries sense multiple access, meaning that we have multiple people communicating on the wire at the same time. Okay? And sometimes we have collisions, and we have a collision that is detected, collision detect, okay? Then that means we're going to handle that collision. We're not going to have any more. We're going to stop. Everyone's going to wait for a little bit and have a random timer so they can start transmitting again. All right? This is one of the cool things that Ethernet does. This is not something you can figure, by the way. Like I said, it's already done for you. Just plug the cable in. All right? Now, your 802.3 standards provides MAC Layer 2 addressing, duplexing, differential services, and flow control attributes. Okay? And various physical one definitions. Yeah, who cares? All right? And that would be like, media clocking and speed attributes. Okay? Now, why am I saying this? 9 times out of 10, all you're going to be doing is working on Ethernet. It's just a term that if I don't explain to you what it is, it's just a foreign name to you. You're like, what the hell is Ethernet, right? Okay? And we use certain media to transfer that data or use Ethernet over top of, which would be unshielded twisted pair, shielded twisted pair, and fiber. Or coaxial. We can use Ethernet over coaxial. We can use it over any media we want to, as long as we can transmit. I can use the copper wires in the wall. Okay? Going from receptacle to receptacle to create an Ethernet connection between those two devices. However, whatever you plug into the wall needs to have a particular protocol to make that communication work. Okay? And yes, there's a device that you can just plug in the wall and use the house wiring as your network cable. All right? Now, Ethernet types. Same thing we covered before, nothing big. Okay? All right? Just know that you have different speeds and make sure that you are buying the right thing for the right thing. Okay? Don't go out and buy a fiber jack, okay, for you to plug into an Ethernet port. It just ain't going to work. Okay? Don't buy fiber cable to plug into your RJ45 jack. Not going to work. Just know what you are buying. All right? And understand there's different types. Do your own research on that. All right? Okay? And look, we've gone all the way down to Cat 1. We've gone to Cat 4, which is token ring, 16 megabits per second. Going to Cat 5, 100 megabits per second. Now notice that the first three are telephone. The fourth one is token. It's called token ring. Okay? And the cool thing about token ring is that unlike Ethernet that allows people to have multi-access and just submit data, okay, and looks out for collisions, token ring was the method of the only person who had a token was allowed to transmit. And if somebody else was using a token to transmit, you had to wait. Okay? Period. You just had to wait until you got your token, and then you could transmit. Okay? Pretty cool, huh? All right? So none of these cables out there, but the most important thing, to be honest, is a RJ45 jack. Look familiar? Looks like a phone jack, right? Except the fact that it's a little bit wider, and it's not called RJ45, a phone jack. It's called RJ11. But we're using RJ45s, okay? That would be this bad boy right here, okay? And notice, hopefully you can see it, the wires that are inside, okay? Now, I hate these things. I gotta get better ones. What are pinouts? When the clip that snaps that cable into place, when it is upside down, facing the floor, okay? All right? And the hole where the wire goes into is facing you, right? That, my friend, is on the far left is pin 1. And as you can see, pin 1, think about it. As I'm putting that in there, the actual clip is on the bottom and the cable is facing you, and I'm plugging it into this jack right here, okay? Where's pin 1? Far left, okay? So when you make your cables, there's also a standard on how your cables should be made, okay? All right? This will make sense because, you know, when I used to make my cables, I just did it by alphabetical order. I mean, since they were both on the same sides, right, I was just making a straight through cable, which we're going to talk about here in a second, right? But I didn't care about the standards as long as I could remember what it was on both sides. Pin 1 matched to pin 1 by color, okay? Now, pin 1 is green with green stripes. Every pair has a solid color and a stripe color, okay? So our pair of greens will be a green solid and a green stripe. Pin 1 is green stripe. Pin 2 is just green, solid, okay? On the other side of my cable, pin 1 must be green striped and must be green solid, okay? That same thing goes for 3, 4, 5, 6, 7, 8. Because it's the same on one side as it is the other, okay, this is how it looks. It's a straight through cable. The cables are going straight through. Now, if I wanted to do a crossover, pay attention now. One thing I want you to focus on. Using this method of straight through cables, we're only using 4 cables, 2 pairs to communicate. 1, 2, 3, and 6. Okay? You pay attention to this long enough, it'll be stuck in your head. 1, 2, 3, and 6. Okay? Alright? Remember, we use electrical signals. So we gotta have a positive and negative. There it is. Right? And look at what this look exactly on how this is done. On one side of the cable, in the actual RJ45, pin 1 is transmit positive and transmit negative. On the other side, is receive positive and receive negative. Now, wait a minute. Does that make sense? No, not from a perspective of cable to cable, but what you're plugging it into. This is the PC side. One side of the cable goes in here. This is your hub. That means your hub has the actual pins 1 and 2 as receive instead of transmit. Wouldn't that make sense? And then 3 and 6, as you are receiving that data on 3 and 6 on the PC, you're transmitting it from the hub side. Okay? Or switch side, either way. Now, check this out. When I have a PC to PC now, what's going to happen? Pin 1 and 2 are both going to be transmitting on the transmit side of the actual network card. So what we're going to do is we're going to cross those cables over so that pin 1 and 2 goes to pin 3 and 6 of the other network card, so the transmit can hit the receive side of the network card. That's why you need a crossover cable. So if I'm going from switch to switch that have the same pin outs, guess what? All right, because the switch pin outs are different than the PC. The PC 1 and 2 are transmits, but the port on the switch pin 1 and 2 are receives. But if I'm going from switch to switch, isn't pin 1 and 2 both going to be receive? Yeah. So I have to create what? A crossover cable. So pin 1 and 2 that are receiving are going to the transmit of pin 3 and 6 of the other switch that I'm connecting to. Because they're switches, those ports are built out differently as far as the receive and transmit is on that particular port. Important to know, guys, because when you go to plug into a switch, all right, and you don't have that auto technology that'll automatically switch to receive and transmit, you're never going to get it to work. You have to know that you need a crossover cable. Okay? All right? If you got a crimper and you got RJ45 Jackson cable, you can make your own right there on site. All right? We got two standards for wiring. 568A and 568B. I don't care which one you choose. Okay? I really care less. As long as you know that these standards are there. I don't care if you go by alphabetical order, like I used to. It still works. If I want to create a crossover cable, I'm going to draw out on my piece of paper pin 1 going to pin 3 and 6, and I'm going to write it out. I'm not going to sit there and try to remember in my head which one is which, because it's easy to screw up a cable. Okay? All right? So, as we are connecting devices, a server or a PC, okay, going to a switch is just a straight through cable. All right? A router and a switch. What would that be? Well, let's think about it. The router and a switch, yeah, that's just a straight through cable. However, and look at the difference on my diagrams, the difference on my cables. A straight line is a straight cable, straight through cable. The dotted lines, as I'm going from the device to device that are the same, I need a crossover cable. Okay? You see that? Now, I don't know why I have a server going to an actual... Okay, you know what? I'm going to leave that alone because I just had I had a brain cramp. Okay, switch to a hub makes sense as a crossover cable. Let me think. Okay, so hooking up a router going to a switch It's just like hooking up a PC. Yes, now I get it. If I'm going to hook a PC directly to a router, guys, I've never done that. I'm really sitting there thinking about this. I've never physically taken a server or a router and directly plugged it into an actual device. But if I can plug a router into a switch, okay, and have a straight-through cable of doing so, then obviously the pinouts are the same as a PC. Okay, that makes sense. I've just never done this before. Now that I'm thinking about it, it threw me for a loop there. All right, notice how things that I should know, right? You will sit there and you question, you'll be like, are you sure you're a CCNA, right? Guys, I'm telling you, at one time, I would be so on point with this stuff, it wouldn't even be funny, okay? All right? I laugh because I'm like, I can't believe that I've never done that ever. And there's so many scenarios where I could have, right? And I can't believe I just never did it on all the labs I've done. And I'm sitting there scratching my head, wait a minute, is that right? Did I do that wrong? All right? And be honest, guys, I really don't care if I'm wrong. All right? You get to that point where you just don't care because you know at one point you knew. And two, it doesn't really matter if you don't know. It really doesn't. If you want to figure it out, go test it out. Then you know. Then your not knowing becomes known. All right? What you don't know now, you'll know in 30 minutes or 30 seconds. It doesn't matter. Who cares? Just move on. Right? I'm over it. Okay? So now, what is an IP address? Okay. This topic we're going to talk into another video because this, if I teach this or say this the wrong way, which I'm going to do, I'm going to tell you right now, I'm going to confuse you. Okay? All right? You need to read this. This is going to be your first reading assignment by me, okay? Because it's very easy. It's up here, okay? It's right here. It's right here, but it doesn't come out the way it should because it's not easy teaching IP addresses and subnet masks and bits. And it's not like I struggle with it, but I struggle with it sometimes. You know, hey, I'm over it. So now, that's going to be our next video, and we're going to stop here, okay? That we're going to have to, I want your mind fresh with a new video whenever you have time to watch it instead of carrying on with the stuff we just talked about. You know, this video is just about Ethernet, and always remember, be strong, be determined, be Cisco.